Deepika. With that eyeball, whenever she look at his mama, her mama, then what happens? Nothing but what will increases? People size, yes, size of the people will be increased. Whenever she come into the class, at that time completely it will be closed. Why? Because she don't want to listen the class. At that time also she will be thinking about her mama only. ಈಗ ಉಪವಾಸ ಬಿಟ್ಟಿದ್ರೋ ಇಲ್ಲನೋ, ನಮ್ಮ ಅತ್ತ ಏನು ಪ್ರಿಪೇರ್ ಮಾಡಿದ್ರೋ ಏನೋ, ತುಂಬ ಹಸು ಆಗ್ತಾ ಇರುತ್ತೆ ಪಾಪ ಅನಿ. ಕರೆಕ್ಟಾ ದೀಪಿಕಾ? So first disease is myopia. And I have to make an instrument by using the ray optics such that she can see her mama by sitting in the class only. Completely like this she will hold and then she will be seeing wherever he goes. Myopia, short-sightedness, whichever you have, short-sightedness or near-sightedness. Short-sightedness or near-sightedness, that is a myopia. So here in myopia what happens? Nothing but by the name what you can say? Deepika can see the short distances or long distances. She can see the long distance whenever her mama is staying, whatever the long it might be. In Gnana Vikasa or Gurukula, she will be seeing from here only. This is the disease, roga. Yen roga andre? The person cannot see the longer distant objects. Don't confuse by the name. Okay, short-sightedness. Sighting means what? Seeing. Short distance he can see, longer distance he cannot see. That is a disease whichever the person got. And then in this what happens? Nothing but whenever the person is observing the object, where the image will be formed generally? Where the image will be formed? On the retina. I will not go much deeper in that. Why? Because I don't have any knowledge in that. Okay, so that I know the myopia and then hypermetropia, what is that, and then what is this? Where the image will be formed? I don't know the ciliary muscles. What is that? Whatever, I don't know anything about that, so don't ask me that questions and all. So here object is kept. Generally whenever the perfect vision is there, at that time the image will be formed on the retina. In the myopia, where the image will be formed? Nothing but in front of the retina it will be formed. Like this. Here the image will be formed. So for the perfect vision, where should be the image should be formed? On the retina. So that I want to correct it. To correct it, what we will use? Nothing but we will use a concave lens. So here concave lens will be kept in front of the eye, and then here the object is kept, and after the number of refractions, what happens? Where the image will be formed? Exactly on the retina. That is how we will correct the myopia disease. So this is the object and then here the image is formed. So which lens we will use here? Concave lens, or which lens I can say it as? Diverging lens. Concave lens or diverging lens. By using that, in the myopia disease we can correct it by using the concave lens. We can form the image on just retina only. So that is about the myopia, and then in this some formula will be there. What is that formula? We will see. So before that, without any concave lens and all, where the image is formed? In front of the retina it is formed. It is corrected by using which one? Concave lens here. What is the lens formula for us? 1 by V minus 1 by U is equals to 1 by F. Nothing but in this questions can be asked that which type of nothing but what is the focal length of the concave lens which is used. That is a type of questions can be asked. And also one more question can be asked, that where the book has to be kept so that he can read the book easily. So nothing but object distance or focal length can be asked in this type of questions. So for that, first of all, whenever we are correcting by using the concave lens here, where the image is formed? Nothing but image will be formed on the far point. That far point also in front of the eye lenses only, whatever our eye original lenses only. So that in front of that nothing but what we will get obviously minus fp only, that is a minus far point distance. So whenever we are correcting by using the lens, actual image is formed at the far point, but now it is corrected that it is moving from here to the retina. So here in the place of v, what I can write? Far point I can write fp, whatever the distance they have given. And also in this I said this myopia, by this myopia what people cannot see, longer distance objects or otherwise shorter distance objects, longer distance objects. So if I say that longer distance is, for example, in front of our eye lens is very smaller. For example, let me take 500 meters is the longer distance only, that is the infinite distance only. So what I can say, nothing but if before this 1 by v value is how much here? Minus far point, that divided by 1 by u is equals to 1 by f. This is the object distance. Object distance also is there in which place, that is in front of the eye only. In front of the eye nothing but what will take here? Minus u only. So that is 1 by minus fp minus of 1 by minus u, that is equals to 1 by f. If object is placed at infinity, if u is equals to infinity, then what will get? U is infinity, then what happens? It will become as how much? 0. Then what will get here? 1 by v minus 1 by infinity is equals to 1 by f. This value becomes how much here? 0. Then v is how much here? Minus far point, that is equals to 1 by f. Then obviously focal length is equals to what is the value here? Minus far point. That is about the focal length of the lens whichever we have used here. Then after that they will ask the power also. Power is equals to ಎಲ್ಲಿ ಫಂಕ್ಷನಲ್ ಹೋಗಿದೆಯಾ? 2 ಫಂಕ್ಷನ್ಸ್ ನಡ್ತಾ ಇದ್ವಿ ಅಲ್ಲಿ, ಸ್ನ್ಯಾಕ್ಸ್ಗೋಸ್ಕರ ಐಸ್ ಕ್ರೀಮ್ ಕೊಡ್ತಾರೆ. ಸೊ ದಟ್ ಪವರ್ ಆಫ್ ದ ಲೆನ್ಸ್, power of the lens P is equals to what is the formula? 1 by f. 1 by f is exactly equals to how much? 1 by minus fp. Clear? That is how the power of the concave lens whichever we have used here will be calculated. Clear? So that is a myopia. Myopia nothing but myopia or short sightedness or near sightedness, nothing but the person can see only shorter distant objects, short sightedness, so that he cannot see the longer distant object. So whenever the person who is having the myopia is looking at the longer distant object, the image of that object will be formed just in front of the retina. So that to correct it we have to use which type of lens here? Concave lens. And then whenever we are using the concave lens, the image will be formed at the far point. So that far point also in front of the eye only, so that only we will take it as minus fp, and then object distance will be minus u only, and the focal length is f obviously, by using the concave lens formula, and we got so and so formula here. And after that whenever the object is kept at infinite distance, why? Because that is a longer distance only. So infinite distance nothing but at that time f is equals to minus far point exactly. Then power of the lens is equals to how much? P is equals to 1 by f, that is 1 by minus fp. That is about the myopia. Next one will be there hypermetropia. In that what happens? Nothing but person cannot see the near distant objects. Okay, for example, whenever I hold the book here, I cannot read the whatever the letters properly. That is a whatever that hypermetropia or long sightedness. He can see the longer objects easily but cannot see the shorter objects. So that is about the hypermetropia. In that again image will be formed after the correction at a near point. Near point it will be formed. Before correction where the image will be formed? Nothing but behind the retina. Clear? So that we will discuss again. First of all, myopia. Myopia, short sightedness or near sightedness. First point, person cannot see the longer distant objects. Longer distant objects. Next point, image will be formed before retina. image will be formed before retina. Next point, corrected by concave lens, corrected by concave lens. Next point, after the correction the image will be formed at far point. Image will be formed at far point in front of the eye lens. Draw both the diagrams, copy everything. ಯಾಕಮ್ಮ ದೃಷ್ಟಿ ನಿನ್ನೆ ಬಂದಿಲ್ಲ? Why didn't you come yesterday? Was not feeling well. Today you are feeling well. Tomorrow? Finished? Syllabus already mugitu, you are still copying like chikkumakkalu only. Step by step, letter by letter. Next, hypermetropia. Which objects cannot be seen? Shorter distant objects cannot be seen. Longer distance objects can be seen easily. So that only long sightedness this one is. Then after that, in this what happens? The image will be formed behind the retina and which is corrected by the convex lens. Whenever the convex lens is used, at that time image is formed at which point here? Near point, minus near point. This here in this hypermetropia, that will be at near point by using which lens here? Convex lens. Whenever you use the concave lens, at that time it will be at the far point. So here image will be at near point. Now everything already story we know that. So here 1 by V minus 1 by U is equals to 1 by F I want to calculate. Then 1 by V, where the image is formed? Where the image is formed? Near point only, right? So that will be 1 by minus NP, near point, minus 1 by U is nothing but what here? Object distance in front of the eye lens only. So only that is minus U again. That is equals to 1 by F directly. Then after that, Here it will be, if I still minimize this, then 1 by minus np plus 1 by u is equals to 1 by f. From here itself we can find out the focal length. Why? Because in this compulsory they have to give the object distance. Why? Because that is kept very near. Here it was kept very longer distance, so only I have taken it as what? Infinity, if not given. If given, you can take that as it is. Then after that, in this power is equals to, what is the formula for us? Power is equals to 1 by f. So that 1 by f value is of course this one only. Clear? Copy that. First copy the diagrams. Up. Hello. Sir, namaste sir. మర్చిపోయారు సార్. సార్ క్లాస్లో ఉన్నా సార్, చేస్తా సార్ నేను ఒక హాఫ్ అన్ అవర్లో. ప్లీజ్ ఎక్స్క్యూజ్ మీ సార్. ఓకే సార్, ఓకే. డన్, రైట్ దట్. ಹೈಪರ್ಮೆಟ್ರೋಪಿಯಾ. ಕಿಶೋರ್ ಸರೇ, ದೇರ್ ಇಸ್ ನೋ ನೀಡ್ ಟು ಪಾಸ್ ಆನ್ ದಟ್. ಕಿಶೋರ್ ಸರೇ ಕಾಲ್ ಮಾಡಿದ್ರು, ಓಕೆನಾ? ನೀವೆಲ್ಲರೂ ಕೇಳಿದ್ರೇ ಕೇಳ್ತೀನಿ ಅವ್ರಿಗೆ, ಓಕೆನಾ? ಬೇಡ, ಇದು ಹೇಳ್ತೀನಿ ಫಸ್ಟು. ದೀಪಿಕಾ ಬೇಡ ಅನ್ನಂದ್ರು ಸರನೇ ಹೇಳ್ತೀನಿ. ಅವಾಗ ಅವ್ರು ಏನಂತಾರೆ ಗೊತ್ತಾ, ಅವ್ರ ಮಾಮ ಒಬ್ಬರೇ ಕೆಮಿಸ್ಟ್ರಿ ಟೀಚ್ ಮಾಡಬೇಕು, ಅವ್ರು ಮಾಡೋ ಮಾಮಗೆ ಆಪೋಸಿಟ್ ನಾವು ಬಂದಿದ್ದೀವಲ್ಲ, ಅದಕ್ಕೆ ನಾವು ಅಂದರೆ ಕೋಪ ಅವ್ರಿಗೆ ಅಂತಾರೆ. ಏನಮ್ಮ ದೀಪಿಕಾ, ಕೆಮಿಸ್ಟ್ರಿ ಅಂದರೆ ಯೂನಿವರ್ಸಲ್ಲಿ ನಿಮ್ಮ ಮಾಮ ಒಬ್ಬರೇ ಟೀಚ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲಲ್ಲ. Like that. Hypermetropia. Shorter distant objects cannot be seen. Shorter distant objects cannot be seen. Right, you have to write it. ಎಲ್ಲ ಬರೀದಿವಾ? ಎಲ್ಲ ನಿಮ್ಮ ನೋಟ್ಸಲ್ಲಿ ನೋಡಿ ಎಲ್ಲರಿಗೆ ಡಿಕ್ಟೇಟ್ ಮಾಡ್ತೀನಿ ನಾನು. The image will be formed after the retina. Person cannot see near distant object corrected by the convex lens. After the correction, the image will be formed at near point in front of the eye lens. Ba, first time ಇವರು ಇಷ್ಟು ನೀಟಾಗಿ ಬರೆದಿದ್ದಾರೆ ನೋಟ್ಸ್. Right, that shorter distant objects cannot be seen. Next point, image will be formed behind the retina na after retina na? ರೆಟಿನಾ ಆಮೇಲೆ ಆಗುತ್ತೆ ಇಮೇಜ್. Image will be formed behind the retina, corrected by the convex lens. After correction, image will be at near point. Copy the derivation also. Yes, next point, astigmatism. What is that astigmatism means? What is that astigmatism means? Old people will get astigmatism. Nothing but the people cannot see the perpendicular objects. Nothing but exactly they cannot see the shape. For example, square shape is there means they will see like this. Okay na? Person means it is not perpendicular object, so only they can see easily. But whichever they are taking the exactly perpendicular objects are there, at that time they cannot see it perpendicularly. Aishwarya, don't eat like this. Are you Gajni? So perpendicular objects cannot be seen and then cannot identify the horizontal and then vertical distances, so that it will be bent obviously. Aishwarya, if you are seeing like that means, please look at this diagram. Then your image will be perpendicular only, exactly. So she is beating like this. That is astigmatism means. Okay, what is that? The persons cannot see the perpendicular object. Nothing but horizontal and then vertical directions cannot be seen properly. It will be bended obviously. So that will be due to the imperfect shape of the eye lens, and also what is that, ciliary muscles also. That is due to the defect of the ciliary muscles. And also how it will be corrected? It will be corrected by using the cylindrical lenses. Cylindrical lenses. What happened to you people? Why you people are disturbing me like this way? Yes? What happened to you? You will talk to that guy and then that guy, this guy, everybody you want around you. Shreyas, any Vishesha? Any Lala? So here it will be corrected by which lens here? Cylindrical lens. Only one point, that is perpendicular objects cannot be seen properly, so that it will be bended like this. Then after that, one more point is, it is due to the defect of the ciliary muscles and imperfect shape of the eye lens. Then last one, it will be corrected by using cylindrical lens. And then write that astigmatism. Nothing, no formulas, nothing will be there, only theory. First point, perpendicular objects cannot be seen properly. Horizontal, next point, horizontal and vertical directions of objects cannot be identified properly. Next one, due to the imperfect shape of the eye lens. And corrected by using the cylindrical lens. And before that, whenever you see this distance, this is the smaller distance I have. Before before the correction, the distance between the eye lens and then image was shorter. Then after that I just corrected by using the concave lens. Then what happening here? Distance is increasing. Here what happening? Distance was longer. Whenever I correct it, then what happening here? Distance is decreasing. That is one more point. And also here, whenever you see the focal length of the concave lens, less or more? Focal length of the concave lens is negative. Focal length of the convex lens is positive, right? Already you know that. So focal length is less here, nothing but what happens? Power will be more. Less focal length, nothing but more power. Here focal length is more, nothing but power will be less. Clear? Write a note point about that. For myopia, as the image formed before the retina the distance between the eye lens and the image is lesser and after the correction this distance is increasing, comma, less focal length, more power. Next point, for the hypermetropia, as the image formed behind the retina, The distance between the eye lens and image is more, between the eye lens and image is more, and it will be decreased by the correction, and it will be decreased by the correction. More focal length, less power. More focal length and next last defect. What is that? Correct na? Biology alli yakirutte physics? Presbyopia. What is that presbyopia means? The person cannot see either near object or far object. Completely blind. So that is the presbyopia. He cannot see the near object as well as the far object. So that will be corrected by using the multiple lenses. Not only one lens, we have to use multiple lenses or by using the spectacles. Okay, I don't know, for this also spectacles only, no, we will use. So what is this people? Right, that presbyopia. And also due to the weakness of ciliary muscles. This one, reason. Okay, na? What you are thinking, I know. She know only one word. She don't know what is the ciliary muscle also. Again and again she is using that word only. Like that you are thinking, no? Then what about you? You don't know anything but you are using again and again same formula only. In Kushi? Full Kushi idare ivattu.
It's 7:09 p.m.
Corrected by using multiple lenses. Corrected by using multiple lenses or spectacles. Biology related topic ಚೆನ್ನಾಗಿ ಬೈ ಹಾರ್ಟ್ ಮಾಡ್ಕೊಂಡು ಬಂದಿದ್ರು. ಡೈರೆಕ್ಟ್ ಟೀಚ್ ಮಾಡ್ತಾ ಇದ್ರು. Done. Finished. Defect of eye is finished. Some natural phenomena due to the sunlight. Which ಅದೇ ಟೀಚ್ ಮಾಡ್ತೀನಿ ಇವಾಗ. Some natural phenomena of sunlight. అరే దీనిలో నన్ను ఎక్కువ క్వశ్చన్స్ అడగకు. నీకు ఈ ఫార్ములాలో ఏదైనా డిఫరెన్స్ ఉందే అడుగు, అంతేగాని ఏది అందుకే కదా నెగిటివ్ వచ్చింది కదా ఇక్కడ -FP. ఎక్కడ వచ్చే ఆన్సరే మైనస్లో వస్తుంది మనకు. ఇవన్నీ తీసుకున్న తర్వాత వచ్చే ఆన్సరే మైనస్లో వస్తుంది. ఓకే, దీని గురించి అడగకు నన్ను. యూ డోంట్ ఆస్క్ అబౌట్ దిస్ ఆర్ యూ డోంట్ ఆస్క్ అబౌట్ దిస్ అండ్ ఆల్. యూ ఆస్క్ అబౌట్ ద డెరివేషన్, ఐ విల్ ఎక్స్ప్లెయిన్ యూ. దెన్ నెక్స్ట్, some natural phenomena of sunlight. Natural phenomena of sunlight. Which are the natural phenomena of sunlight? Yes, we know only one, that is rainbow. Then one more is sky appears in which color? Yes, sky in blue color. Then sunrise and then sunset. In which color? Red color. Color, which color? Then one more is cloud appears white. Cloud appears white. These and so these and all are the natural phenomena of sunlight. And what is the reason why they appears like that? Means due to the refractions and dispersions and total internal reflections. It will undergo the multiple process. In this rainbow will have the primary and then secondary rainbow. In primary rainbow, three phenomena will take place. That is, one is dispersion first, refraction with dispersion. Next one is total internal reflection. Then after that, refraction. These are the three phenomena will be taken in the primary rainbow. At that time, red appears on the top and then violet appears on the bottom. Whenever you come to the secondary rainbow, in the secondary rainbow, four phenomena will take place. Along with that three, one more external total internal reflection also will happen. Total external reflection also will take place. So, four process will be there. At that time, red appears at the bottom and then violet appears at the top. In that, only one difference will be there in between them, that is the angles. So, at how much angle it will be bended, nothing but it will be refracted. That is the main thing in this primary and then secondary rainbow. After that, we will discuss about the scattering. In this scattering only, these colors of the sunrise and then sunset and then sky appears in blue color and then clouds appears in the white colors will come. What is that scattering of light? Nothing but whenever the light is traveling through the medium, in the medium obviously dust particles are there. Whenever the light is entering into the dust, at that time what happens? Dust particle will absorb the radiation and after that it will emit the radiation. Why? Because it cannot absorb completely. What is the reason? It is not a black body. Whenever you take the black body, at that time it will absorb completely. So, a dust particle will not absorb the light completely. It will absorb and also it will emit the remaining light. So, whatever it is emitting, at that time it will emit in different wavelengths. So, that wavelengths will create the whatever the colors we are getting here. So, that is known by the what is that Raman effect also. What Raman effect will says? Intensity is inversely proportional to lambda power 4. And also in that again elastic scattering will be there, inelastic scattering will be there. The elastic scattering nothing but whatever the dust particles you are taking, while emitting the radiation, they will not change the wavelength. Whatever the light falling on that, it is falling with some wavelength. After emission, after absorption and then emission, the wavelength will be same again. That type of emission is known as the elastic scattering. Then whenever you come to the Raman effect, that Raman effect is perfectly defined for the inelastic scattering only. What is the inelastic scattering here? Wavelength will be changed. After the radiation, wavelength will be changed. So, after the scattering, I am sorry. So, that is about the Raman effect and then one more effect will be there, that is something will be there, rebug something will be there. I will tell you that. Relay scattering will be there. Relay scattering nothing but it is defined for the elastic scattering and then Raman scattering is defined for the inelastic scattering. Raman effect will be. So, this is about the scattering of light and then before that we will have the rainbow. Okay, I will explain about that. Write that some natural phenomena due to the sunlight. First one is formation of rainbow. Blue color of the sky. Blue color of the sky. And red color of the sunset and sunrise. And white color of the clouds. And white color of the clouds is due to the different phenomena. Those are refraction with dispersion, total internal reflection, refraction and scattering. First three processes will be for the rainbow. Last process whatever is just scattering, that will be for the sky colors and all. Okay na? Then here rainbow. In rainbow, two types of rainbows will be there. One is primary rainbow and also secondary rainbow. So in primary rainbow, what happens? Nothing but here obviously raindrop will be there, rain droplets will be there, and also where the rainbow will appears, nothing but rainbow will appears exactly opposite side of the sun. Okay, sun is there, sunset is there in this direction, nothing but we will see the rainbow on the opposite side. Okay, it cannot be formed on the same side of the sun. Okay, that you have to remember mainly. And also here, whenever the sunlight is entering in the droplets of the rain, at that time the raindrop will contain what? Water only. Water is having the refractive index of how much? 4/3. Whenever it is having some refractive index, the light is entering from the air to water. At that time what phenomena will take place? Refraction phenomena will take place. And also total internal reflection also will take place. And also whenever it is entering into the transparent medium, in the prism already you know that whenever the white light is entering into the prism, what process will take place? Dispersion. So here first and foremost process is refraction with dispersion. Refraction with dispersion. Then only light colors can be seen. Without dispersion, how the colors can be seen? Only refraction is there, nothing but only the light will be bended, that's it. So we are seeing the colors, nothing but the white light is dividing into the number of colors. So obviously which process that is? Dispersion process only. So that refraction with dispersion. Then second process is total internal reflection. Then third process is refraction. These are the three phenomena will take place in the primary rainbow. And also now whenever the sunlight is entering into the raindrop like this, this is the sunlight. Then whenever the sunlight is entering, obviously which process will take place here? Refraction and then dispersion will take place. So first I will change the angle. Like this light is entering, then what happens? Refraction will take place so that it is bending. Then after that what I said here? Total internal reflection. Is there anything coming out here? Nothing is coming out. Internally totally it is reflecting, so that only total internal reflection like this it will take place. Angle of incidence is equals to angle of reflection here. After that again which phenomena is taking place here? Refraction phenomena. Obviously the light is dispersed, so that you will get the different lights here. So one is a red, another is a violet. So this is a place wherever we are observing, and also here the human eye is present. Now this is the red color we will get, this is the violet color. Which will be the outer side? Nothing but red will be on the outer side and then violet will be on the inner side. It will have the angles. So what are the angles here? Any idea about the angles? 53, 50, 42, 40. Any idea about that? So in the primary rainbow you will get the angles as which is bending more here obviously. Bending andre angle with respect to the horizontal direction. Red is right, red is having more angle here. So that this will have the angle of 53 degrees, this will have the angle of 50 degrees only. This is about the primary rainbow. Next one is secondary rainbow. In secondary rainbow again the same process only, but one more phenomena will take place, that is a reflection, total external reflection. One is total internal reflection and also external reflection. So it's okay, don't scold me inside. Anybody like that? Uday? ಜಲ್ದಿ ಬಿಟ್ಟಿದೆ ಅಂದರೆ ನಾನು ಫಸ್ಟ್ ಮನೆಗೆ ಫೋನ್ ಮಾಡಬೇಕು ಇವತ್ತು. ವೆನಸ್ಡೇ ಫಸ್ಟ್ ಮನೆ, ಥರ್ಸ್ಡೇ ಸೆಕೆಂಡ್ ಮನೆ, ಲೈಕ್ ದ್ಯಾಟ್. You kept any timetable for them? So this is the sunlight which is entering. So here how many process will take place? Nothing but 4 process. One is refraction with dispersion, then total internal reflection, total external reflection, and the fourth one is refraction. So here refraction with dispersion first. Then what happens whenever the sunlight is entering horizontally like this? Then what happens? obviously what happens, it will get refracted, so that the sunlight is getting refracted in this manner. Then after that what happening? Total internal reflection. Internal reflection nothing but it will not come out directly, it will go and then hit here. Again one more reflection is taking place, that is the external reflection. Nothing but what happens, after the reflection the ray will come outside, so that here it is coming outside in this manner. This is the first internal reflection, this is the external reflection will take place, and after that obviously it is coming out of the water medium. Then which process will take place? Refraction process will take place. Then again light will be bent like this, and also it will disperses. So again two colors will be formed, last two colors I am saying about, all the colors will be there by the way. Then outer side will be there which one? Violet and then red. This will have more angle here, that is 42 degrees, and here it has 40 degrees. That is about the secondary rainbow and then primary rainbow. You have to mainly identify the difference, that in this red will be outside and then violet will be inside. Nothing but whenever you see the rainbow, on the top red will be there, on the bottom violet will be there. This is the rainbow formation here. So on the top red, on the bottom violet. So don't think that here violet is coming first, so that violet is on the top. So here this is the formation of rainbow, this is the shape of the rainbow. So on the top side red, on the bottom side that is violet. In this it is different, again exactly opposite phenomena. In this 3 process, in that 4 process, there one more external reflection we will get. Here only internal reflection and also angles. Clear? That is about the primary and then secondary rainbow. Right, that primary rainbow and then secondary rainbow. Side by side you write directly. As it is you write. Why to waste the time on that? Ritual, water bottle తీసుకురా పాప. ఏం కలుపుకోవచ్చురా? ಫಿಸಿಕ್ಸ್ ಕ್ಲಾಸ್ ಹೌದಾ? ಏನೋ ಮಿಕ್ಸ್ ಮಾಡ್ಕೊಂಡು ಬಂದಿರೋರು. ಏನು ಉದಯ್, ನಮಗೆ ಕರೀದು ಅಂದರೆ ಸ್ವಲ್ಪ ಸ್ಟ್ರಾಂಗ್ ಇರೋದು ಕೊಡ್ತೀನಲ್ಲ ನಾನು ಅನ್ಕೊತ ಇದ್ವಾ. ನೀವು ರಜಾ ಯಾಕೆ ನಗ್ತಾ ಇದ್ವಿ? ఎక్కడ పైనుంచి తెచ్చావా ఇక్కడ నుంచాను? పైనుంచి తెచ్చావా ఇక్కడ నుంచాను? ఇక్కడ నుంచాను. చల్లగా ఉన్నాయి వాటర్ బాగా. ఫినిష్డా? మేక్ ఇట్ ఫాస్ట్. డయాగ్రామ్స్ ఆర్ నాట్ ఇంపార్టెంట్, జస్ట్ డ్రా లైక్ దట్ రఫ్లీ, లైక్ ఉదయ్. Next one is scattering, last topic. Tomorrow we'll start the system of particles. Scattering of light. Next one is scattering of light. Applications. Scattering of light applications. Whatever the remaining 3 applications are there, no, that you write. Sunrise, sunset, sky and clouds and also etc. I don't know, I think spelling is wrong. Correct spelling? Whatever it might be. Relay scattering. Relay scattering, that is relay scattering. So before that, what is the scattering means? I said whenever the light is traveling in the medium, the dust particles will absorb the light and also they will emit some radiation. That emission is known as a scattering of the light. And also in this scattering, 2 types of scatterings will be there. I said one is elastic, another is inelastic scattering. For the elastic scattering, what is the elastic scattering? Nothing but the wavelength does not change before and then after. Before absorption and then after emission, the wavelength is not changing. That is the elastic scattering. Inelastic scattering, nothing but the wavelength will be changed obviously. And also here 2 types of scatterings will be there. In both of the experiments, the intensity is inversely proportional to, the intensity of the scattered light is inversely proportional to the lambda power 4. So in the relay scattering also, and also in the Raman effect also, Raman effect or relay scattering, in both the cases intensity of the scattering light is inversely proportional to lambda power 4. And also relay scattering is defined for the elastic scattering. Elastic scattering, nothing but what I can say, lambda is changes or not changes? Not changes, that is constant. And then in the Raman effect, it is defined for the inelastic scattering. Inelastic scattering, and also in this also the intensity of the scattered light is inversely proportional to lambda power 4 only. And also by using the Raman effect only, Raman is explained the why the sky is appearing in blue color, and also why sunrise and then sunset is there in the red color. Those will be explained, those are explained by the Raman effect only by using the scattering of, which scattering this is? Inelastic scattering. Lambda will changes, wavelength will changes, then only it will appears in that colors. So whenever you come to the sky appears in the blue color, for that what happens? Nothing but here the blue light will have less wavelength, more wavelength as compared to red. Less wavelength. Less wavelength, then what happens? Less wavelength, nothing but intensity will be more. So only whenever you are looking at the sky, by just standing on the earth, at that time you will feel that sky is in the blue color. Okay. And also whenever you come to the what is that, sunset and then sunrise colors, at that time what happens? The angle of the incident light will be different at that time. Why? Because the sun will go on to the horizon, near the horizon. So at that time, due to the change in the angle, then what happens? Nothing but red will bend more than the whatever the blue color here. So only the sunset and then sunrise will appears in the red color. In this mainly you have to understand is the sunset and then sunrise colors and also sky color will be just based on which phenomena here? Raman effect, which is based on the inelastic scattering. In both of the scatterings, the intensity is inversely proportional to lambda power 4. That is only one formula is there, that is it. Clear? Write that. Scattering of light. When the light enters into the dust particles of the medium, when light enters into the dust particles of the mediums, light enters into the dust particles of the mediums, it absorbs the light and also emits the radiation. Emits the radiation. This phenomena is scattering. This phenomena is scattering. In that next line, elastic scattering. Elastic scattering. Wavelength of the light does not changes. Wavelength of the light does not changes before entering into the dust particle and after the emission of radiation. And after the emission of radiation. Then inelastic scattering, wavelength will changes. Wavelength will changes. In the next line, wavelength will changes. Next line, in both elastic and inelastic scatterings, in both elastic and inelastic scatterings, the intensity of scattered light, is inversely proportional to lambda power 4. Is inversely proportional to lambda power 4. Write the equation. I is inversely proportional to lambda power 4. First one is Rayleigh scattering. This is ray, R-A-Y. Rayleigh scattering. Rayleigh scattering. First point in that, defined for elastic scattering. Defined for elastic scattering, lambda constant, intensity of scattered light is inversely proportional to lambda power 4. Inversely proportional to lambda power 4. Raman effect. Defined for inelastic scattering. Defined for inelastic scattering, lambda is not constant. Lambda is not constant.